Okay, today we're going to learn about arithmetic sequences. We're going to first determine if a sequence is an arithmetic sequence, then we're going to find the next three terms of an arithmetic sequence, and then we're going to write the explicit equation for an arithmetic sequence. A sequence is just a set of numbers in a specific order. The terms in a sequence are a sub 1, a sub 2, a sub 3, a sub 4, all the way out till you get to a sub n. What that means is we don't know how many terms are actually going to be in the sequence, that they just go on forever. What this a sub n or a sub 1 means is that that is your first term. Your a sub 2 represents your second term. A sub 3 represents your third term. And a sub 4 represents your fourth term, and this will keep going on. It'll list out your number of terms. So if I gave you a sequence that was 1, 2, 3, let me change that. 1, 4, 7, 10, and so on, then 1 would be known as a sub 1, or your first term. 4 would be known as a sub 2, or your second term. 7 would be known as a sub 3, or your third term, and 10 would be known as a sub 4, or your fourth term, and so on. Your arithmetic sequence is a sequence in which the difference between successive terms is a constant. The graph of this is linear. So when it says the difference between successive terms, I just had this sequence. And when it means successive terms, it says you're going to take two terms in a row. 10 comes first. So we would take the difference between 10 and 7 and get 3. We could do the same thing with 4 and 7 and take 7 minus 4. We could do the same thing with 4 and 1 and take 4 minus 1. And if you notice, each time we got 3. And that's how we know it's a constant. It's the same value no matter what two terms we take. Your common difference, we call it d when we're talking about sequences. It's not the same as when we're talking about distance. This is the difference between successive terms in a sequence. So in that sequence I just had, we could take any two terms that were in a row. When we subtract them, this gives us 3, and 3 is what is known as d, the common difference. So on example 1 it says, first of all, determine if the sequence is an arithmetic sequence. If it is, find the common difference. So we're going to look at this pattern and say what is occurring from term to term. It looks like here we're adding 2, we're adding 2, we're adding 2. Because it's adding, or it could be subtracting to be arithmetic, but in this case it is adding, then we would say yes, it's an arithmetic sequence. Because it is, we would say find the common difference. The common difference, if we take successive terms, I'm going to take the 2 and the 0. 2 minus 0 is 2, and you can see that this term that we add by, this plus 2 each time, is actually the same as the common difference. So there's two ways to find it. You can find it by taking the difference of successive terms, or you can say what is happening to my sequence. In this case, what is going on to get, or what happens with the first term that will get us to the second term. Okay, so with b, we're looking at the same thing. What I would suggest when you have fractions is to get a common denominator. So we can see that the common denominator here is 16 for each of these. The last one's already 16. And so we rewrite 1/2 as 8/16, 5/8 as 10/16, and 3/4 as 12/16. And then we're going to look. It looks like we're adding each time 2/16 to get to the next one until right here. From that 12 to the 13 we only add 1, and so since that value is not the same, we do not have a common difference, and it is not arithmetic. The equation for an arithmetic sequence is this: a sub n This is the value of your nth term. A sub 1 is your first term. D is the common difference. And N is the value of the nth term. So if they said we are looking for the 17th term, N would be 17. If they say we're looking for the nth term, then we don't get to replace that N with anything but N. So in this example 3, it says write an equation for the nth term of the arithmetic sequence, then graph the sequence. We know that it's arithmetic, it tells us that. So once we know it's arithmetic, we have to find D. It looks like it's adding 4 each time, so we're going to say the common difference is D. The only other thing you need to identify is a sub 1, and that is your first term. In this case, it's negative 12. Then we're going to use that formula up above, which says a sub n equals a sub 1. In this case, it's negative 12. Plus n, we don't know n, minus 1 times D, which is 4. And we're going to distribute the 4 to get negative 12 plus 4n minus 4. From here we'll combine like terms, and I'm going to reorder it. So I get 4n, negative 12 minus 4 is negative 16. And then we're going to look at this for just a moment. I'm going to get a different color. If I were to write this y equals mx plus b, can you see the similarities between these two equations? You should recognize here that they are both linear equations. Another way we can write this is f of x equals mx plus b. And if we wanted to actually use the same numbers, we could say y equals 4x minus 16, or f of x equals 4x minus 16. Both of these are still the same equation, they're just written differently. When we are using sequences, we start using this a sub n, so that you'll learn later why we use that. It's just we need to get familiar using it. If you can recognize them, that they are still the same and it's still a linear equation when we're doing arithmetic sequences, that will be helpful. So if you were asked to graph this equation, we could graph it in slope, intercept, and go down 16 and then use our slope up 4 over 1, up 4 over 1 to create a linear graph. Or we can come back up here and look at our sequence. Our sequence says our first term is negative 12, so I'm going to say our first term is negative 12. Our second term is negative 8, the third term is negative 4, and the fourth term is 0. And then I'm going to create a table and then graph that. So it says I'm going to go over 1 down 12. I'm actually going to go by 2's here and by 1 here. Even when I go over 1 down 12, I'm off my graph, so I'll go over 2 down 8, 2, 4, 6, 8, over 3 down 4, and then over 4, 0, and then we create this line. If it were to keep going down 2 over 1, down 2 over 1, you would see eventually we would cross down here, and that point right there should be negative 16, the y-intercept, which you could get from our equation there. So I don't really care how you graph them. You can graph using this table we created, or you can graph using your equation that we came up with. So on example 2, we're going to do the same thing. You have to identify a sub 1, that's your first term, and your common difference. It looks like we're adding 2 each time, so your common difference is 2. And then we'll use our formula, a sub n equals a sub 1, negative 1, plus n minus 1 times 2. We distribute the 2 through, we get negative 1 plus 2n minus 2. We combine like terms and we get 2n minus 3. At this point you can decide either to graph using this equation, or you can use your sequence to create a table. I'm going to go ahead and graph by the equation. It says you're going to go down 3. Our slope is up 2 over 1. Let's see if I can draw that straighter. A little better. And there's our line. If we wanted to check our sequence, and see if those numbers are correct, remember that -1 is our first term, this is our second term, our third term, and our fourth term. So it says that we would go over 1, down 1. On my graph it's right here. Over 1, up 2, it's on my graph right there. Over 3, up 3, and you can see that those points are still on my graph. So whether I use the table that I can create up here or the equation that I came up with, I should still be able to get the same line. On example 4, it says use the following arithmetic sequence to find the following. So it gives us our sequence right here. When it gives you a sequence, I would first find a sub 1. Seems like we always need that value. In this case it's 1. Then I would also find the common difference. We know it's an arithmetic because it tells us. And you can see that here it's adding 9 each time, so our common difference is 9. It then asks you to find the 12th term. Now, you could list out, right here we have the first 4 terms in our sequence. You could list out 12 terms and find them by adding 9 each time. It might take you a little while. So instead of doing that, we're going to use our formula. A sub n, and in this case n is 12, so I'm going to put a sub 12 equals a sub 1 plus n is 12, minus 1 times d, which is 9. Then I'm going to do just the math here. 1 plus 12 minus 1 is 11. 11 times 9 is 99 plus 1 is 100. So your 12th term would be 100. Now, this is not the only way to solve this. Like I said, you could list them out, and there are actually other ways. We had somebody in our class discover a different way to do this, and there are many different ways to solve this, but this is pretty fast and accurate, so I'll probably continue to show you to use this as well. So with then on part B it says which term of the sequence is 388. So this is that number that we found that it was 100 for the 12th term. We need to find what term gives us 388. So that's going to actually replace the a sub n in our equation. So instead of a sub n, we're going to write 388 is equal to a sub 1, in our case it was 1, plus n, we don't know, we're trying to find that, and minus 1 times d, which was 9. And then we're going to solve this. 388 equals 1 plus distribute the 9, 9n minus 9. We're going to combine like terms. 1 plus a negative 9 gives us negative 8. Add 8 to both sides. We get 396 equals 9n. Divide by 9 on both sides. I ran out of room there. Divide by 9 and n gives you 44. So our 44th term in our sequence would give us 388. And again, there are other ways to do that. This is the way I'm going to choose to show you. So good luck with your assignment. It's 6-4 Arithmetic Sequences worksheet. You might want to start on some of those word problems on the back. And they're going to be like example 4. You want to start out by identifying what you have so that you know what to replace in your equation. Good luck.